Okay, c'est l'heure. Time to start. Yes, so our next talk is going to be about using recommender systems for simplifying software documentation. I think a very interesting topic. Let's welcome our speaker, Arturo Amor from INRIA in Saclay. Yeah, join me in welcoming Arturo.
So thank you everybody for being here. As he already mentioned, I'm going to talk about recommendation system for examples in the sphinx-gallery. So first, a word about me. I have a PhD in particle physics at the National University of Mexico, called UNAM. I'm a part of the scikit-learn documentation team since its creation, and that's a week ago. But I've been contributing for almost 2 years now. So I'm also in charge of the MOOC machine learning in Python with scikit-learn. I don't know if anyone from here has already followed it. It's high quality content, good for starters. But even if you are not a starter, it's very good for good practices. So stay tuned for the MOOC. It's hopefully going to start on October of this year. So who in this room has ever, contributed or maintained a project's documentation? Okay, quite a few. And who has ever felt lost as a user in a large example gallery? Like you don't find yourself. Okay. So we can agree that there's a problem in sorting the examples. And like for instance, who has struggled to decide where to place a complex example that touches so many subjects? And yeah, maybe this is a bit of a more specific question. But what I want to present is an option for avoiding manual cross-linking, and it's going to make a lot easier the maintenance of the documentation of a project. And the tool for doing so is a recommendation system. And the user case, for instance, this is an example in the scikit-learn gallery. I want you to focus on these clustering text documents using k-means examples. It's currently in the module for text documents, but you could as well place it in a clustering module. It's relevant. And you could also, why not, put it in the module of real-world datasets because it's trained on the 20 News group. So it's hard to decide where to put it. So the solution that we are proposing is a recommender system. And there are several kinds of recommender systems. For instance, there's the content-based recommender system that uses the item features to define similarity, but has no memory whatsoever of user interactions. And this is important, for instance, because we don't need to track cookies or anything from the users to make the recommendations. There's also the item-based, which also uses the item features to define similarity, but it does have a memory of user interactions. For instance, if you have seen cat videos, you will probably like large flying videos, right? Also, there are, for instance, user-based recommender system that uses the features of the user to define a notion of similarity, and it does have a memory of the interactions. For instance, in this example, I said that maybe the system can use the number of cats of a given user as a proxy for how much they like wine. But as you may notice, this can feed on and feed back on prejudices. So we also don't want that. And there are some hybrid methods that may combine both item and user features to define similarity, and even change different kinds of recommendations depending on the case. For instance, in for recommending a film, you can say like, maybe you can put a thumbs up or thumbs down if you didn't like the film, but also it can recommend it based on the similarity of actors, actresses, or kind of film, or whatever. So as I was saying, we're going to focus on content-based recommendation systems because they don't rely on users' data, and that means respecting their privacy in general, but it also doesn't depend on their behavior or the popularity of a given content. It's mostly about its relevancy. So other kinds of recommender systems create bubbles in the sense that you only see what is more popular. They are also light models in the sense that you don't need a database of 10,000 users to train it, and algorithms are typically smaller also. What else? It's transparent because recommendations can be easily explained by features, but the cons is that it's limited to the items features. If they are not high-quality features, then the relevancy may be not so good. And also, if you have a cluster-like structure in your neighbors, you can end up inside a bubble once again. So that's also not very good for getting to know different features or different uses if you're a new user, for instance. Anyway, I've been talking about similarity, but similarity means choosing a metric. And here we are going to use cosine similarity because it's very good with high-dimensional sparse data, such as text. And it basically means that, for instance, if you have a document in pink, which is hello world, and you have a second document in green, which only says hello, then you can draw a point here in the counts space for the pink document or for the green document, and you only care about the projection of one onto the other. And this is very useful for continuous features also. There are some other options. For instance, there's the Jacquard index, which only accounts for the number of elements in the intersection divided by the number of unique elements in the whole corpus of text. But we are going to use cosine similarity because we care about frequency, and we introduce the frequency of a word as a proxy for its importance in a document using TF-IDF. I don't want to enter a lot into the detail of this, but the idea is that you give more weight to rare items across a set of documents. And inversely, if you have terms that are quite common in the whole corpus, like articles, ve, a, or whatsoever, they will have a 0 weight. And this, multiplying by a TF and an IDF, brings us to continuous features, and that's why we need the cosine similarity. Okay, we also have to choose a model. For instance, for unsupervised models, we usually use neighbors-based models, like KNN or something like this. They are good in the sense that they do not require user feedback. As I was saying, it's important for us to respect privacy and to give the same recommendations across different users, mostly based on the content itself. And it's very useful for high-dimensional content, such as text. Anyway, you could also use recommendation systems that are supervised models, such as classification, for, like instance, saying if a user will like an item or not, or you can use regression to say, like, this user has an 80% probability of liking this film. It does require user feedback, and it's useful if you want something more advanced in terms of modeling. For instance, if you want your company to benefit somebody who paid premium so that their content is recommended more often. But okay, let's stop about talking and show you how it actually works. So this is still work in progress. There's a PR in sphinx-gallery. And this is my local build of the scikit-learn example gallery. And I wanted you to notice this example just at the end. You remember the working with text documents, and there's clustering text with k-means. So if you navigate through this example, at the very end of it, you will have an extra feature, which is this related examples. Here, I set the number of examples to 5 because it aligns very well with the width of the page, but you can tune it in your own library as you wish. And you can notice that indeed the closest example, the most related example, is about k-means, so it makes sense, right? And the second most related is also quite relevant because it's classification of text. So it's about text. The first one is about clustering. The second one is about text. The third one is for chance in clustering, chance level in clustering metrics. And the fourth one is more about the vectorization of text documents. So all of them are quite relevant, and even if this particular example belongs to the clustering module, you will have a quick access to it because it's close related, it's relevant. And this is a happy example, but one has to be self-critic. And let me show you, for instance, in the ensemble methods, there's this particular example on comparing random forest and histogram gradient boosting. It's a very well-done example by a nice guy. But anyway, the point here is that we are using California housing dataset to benchmark both training and predicting time versus the test accuracy of both algorithms. So let's see what the recommender system thinks is the most relevant related content. And is this example here, which is a sample pipeline for text features. So if you think about it, it has nothing to do with the random forest and histogram gradient boosting, because this is using, this is displaying mostly how to tune the parameters of a complement naive bias. So we are not even using the same algorithm. So why is that? We can scroll a little bit more, a bit more, and guess what? The algorithm is thinking that both are quite related because we have the same plotly plot. And these are the only two examples in the whole gallery that use plotly for graphics, for plots. So this could be a bug, or this could be a feature, if you are optimistic or not. Because as I was saying, you can have a cluster structure, so you can create a bubble of recommendations like you always get inside the same recommendations. And if you want to explore and go beyond the content that is related, maybe this kind of buggy things may help you discovering new things. It allows for creativity. But if you look at the closest example to this particular one, is not the comparison, the benchmark of random forest versus gradient boosting trees. It's something that is actually quite related. So it's classification of documents. And I also have a proof of concept for the matplotlib gallery. You see they have a bunch of examples. So let's randomly pick one. Let's say this one, which is filling the area between lines. And the recommendations at the end, I set the number of recommendations to 4. And the most related is indeed shade regions defined by a logical mask using fill between. And the other ones, I think, is also fill between. Yeah, so it works. And also, Matplotlib has the example gallery, but it also has the tutorials. And the tutorials also have these kind of recommendations at the end. So yeah, you can do use the same gallery configuration for your sorry, got distracted. Yeah. I mean, it works in subsets of the gallery. You can have several galleries inside your gallery. That's what I mean. So that's it for the demo. And if you want to give it a try on your own project, you can use pip install -u and then this whole string that will fork my PR. And you can enable the recommendation system in your sphinx-gallery config. It's a dictionary, so you will have to pass enable equals to true and the number of examples equal to whatever you want. Just be aware that you may need to add numpy to your dependencies, just in time. So this QR is only for a direct link to the PR. There used to be a proof of concept, but it's not rendering. So yeah, if you want to take a look at the actual code of how I implemented it, it's on the QR. So that's it. Thank you.
Thank you, Arturo. We have time for questions. Actually, the session extends 5 minutes into the lunch break that starts in 5 minutes, okay? To avoid confusion. Any questions? Well, maybe I could start with one while the others are thinking. I was wondering, since this is data-driven, to which extent does the quality of these recommendations depend on the number of documents available in the documentation? I mean, Matplotlib and scikit-learn are, by comparison, huge projects.
Yeah.
Lots of documentation content.
Yeah.
Have you run any kind of sensitivity test to see what happens if you just feed a fraction of the documents into it? Could a small project also benefit from this? And maybe finally, would it make sense to even pool documents across other documentations?
Documentation. That could be nice, actually, but I have to think about it, how to do it.
Feed training or so.
Yeah, like the scikit-learn gallery. Yeah.
Matplotlib or plus.
Yeah. I mean, could make sense.
Or
at least
machine learning libraries in the scikit-learn ecosystem.
At least what we try to do is during the narrative, I don't know if in this particular one we do, but for instance, here we say like, we can also use Plotly Express parallel coordinates, so we link to the documentation, but yeah, I guess we could do better. And regarding the other question, yeah, I have another proof of concept, for the sphinx-gallery. They have their own mini gallery, and they actually have a tiny gallery, which is even smaller. And yeah, I mean, it just loops a bit more because it's so small that there's not a lot of things to see. But yeah, for instance, here you have this example, and it says like, okay, drawing random lines is.
So you would say it also works with smaller projects?
Sure. I mean, it's harder to get lost in a smaller project, so it's not that relevant, but it works.
So you used TF-IDF with a cosine similarity.
Yeah.
Have you also looked at order embeddings and order metrics here?
No, I haven't tried.
Okay. And
the alternative actually that we tried at the very beginning was to use the, I don't know what's the name of the thing, but just extracting, the sphinx-gallery extracts some keywords from every document. Like mostly those that are going to be cross-linked. And those we tried, but it degrades a bit the quality of the recommendations. It's way faster, but I mean, this for building the scikit-learn gallery, it takes, I would say, 20 seconds maybe, by far, my most, in my laptop, so it's quite fast.
Hi, with the approach you took, do you think it would be like an easy step to add, say, weightings or a way to tell the algorithm not to care so much about Plotly as a correspondence? Or would that require a completely new approach?
Yeah. I mean, another option would be like to pass a dictionary of things that one can ignore from the examples. I have to think how to do this, but it's doable. But as I was saying, could be a feature, I'm not sure. But yeah, it's true that it can give you more flexibility on the configuration of your recommendations, yeah.
Did you try using like a small language model instead of TF-IDF for the vector generation?
Actually, the problem here is a bit to avoid adding extra dependencies because the ecosystem is already so, intertwined, that adding an extra dependency always means more manual control, in a sense, maintenance. So yeah, even the PR, if you go to look at the code, I didn't use scikit-learn because we didn't want to add the dependency of matplotlib or sphinx-gallery on our library. Also because I didn't want to be the guy pushing like, you should use scikit-learn. So it's also, in that sense, NumPy is quite standard, and we prefer to do that.
Thank you so much. It's time to close the session and enjoy lunch.